Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you're doing good. In this, we're going to see paint house 4. Now, before starting off, just a quick request. If you guys like the video, especially these contest discussion, please like it so that our motivation keeps same. Now, it simply says that you are given an even integer n. That's the biggest thing. Please don't forget this condition because n is even, which means I always have even number of houses. For example, let's say again there are 4 houses, there are 6 houses. Next example. So let's take a bigger example. I have in this case 1, 2, 3, 4, 5, 6, 7, 8. I have 8 houses. Make sure again I'm repeating n is even. Cool. Let's proceed forward. It represents the number of houses arranged in a straight line. I have some houses arranged in a straight line and a 2D array cost, basically of size n into 3. If I have n houses, which means that each house will have 3 variations, or I should say 3 colors, where the color is nothing but for the index j. As you can see, if I have 3 colors, which means j equal to 0, j equals to 1, j equals to 2, it represents the color 1. I should say C1. Let's say color 1, this is color 2, and this is color 3. Again, they are numbered 1, 2, and 3. That is the reason I'm just referring C1, C2, C3. So they are referring with the color J plus 1. Index plus 1 is the corresponding color name itself. Now, to make the houses look beautiful, obviously, to make them look beautiful, they should satisfy the condition. First condition is that no two adjacent houses are painted in the same color. Okay, which means that 2 houses, if this is having a green color, it can have any different color. It can be either pink or blue. Again, considering, let's say these you have these different colors, so it just said adjacent houses should be painted in a different color. They cannot be of the same color. So this is not possible. This is not possible. Next condition is that houses equidistant from the ends of the rows are not painted in the same color. What they mean by that is that if I see the house, let's say this house is painted as a green. So obviously I know that the neighbor houses cannot be painted green. So they cannot be painted green here. But they're also saying that if I go in this specific row of my houses, from the end, equidistant is, as you can see, it is at the second location. So this is also at the second location. This is equidistant. This location is called as equidistant location. This also should not be painted the same color. Thus, this also cannot be a green. Okay, you have to return the minimum cost. What is this cost? Because you are given the cost of each color. As I told you, you have 4 houses: first house, second house, third house, fourth house. For each house, the corresponding 3 colors I told you have. For each color, you are given this cost. For each color, you are given this cost. This cost. Thus, ultimately, you have to tell simply what is the minimum cost such that both the conditions are satisfied. Now, obviously, if I just simply give you again, I'm just erasing this portion, but I will come back to it later on. But if I simply give you a task that again, simple, go forward and at a random location, you have now 3 options. Obviously, you have now 3 options. First option is to, let's say, put the green color. Second is to put the blue color. Third is to put the pink color. For every house, you will have 3 options. Isn't it that I will try for all 3 possibilities? Whichever possibility gives me minimum cost, that's my answer. Obviously, this gives us the direction of trying for recursion, which ultimately also means that I am simply going towards a DP approach. Again, I can memorize this thing also, right? Yes. But the special part is that before even painting it, or about or think, or when you're about to think to paint this specific index, again, let's, if I put the indexes 0, 1, 2, 3, 4, 5, 6, and 7, if before even about to paint this index with any specific color, I should be knowing one very major stuff. What is the previous color I had painted so far? Is it sufficient? You might say, Aryan, you should also know the next color. I'll say, not really. Why not really? Because obviously I'm going from left to right. So I'll paint it accordingly. Then you might argue that, okay, this satisfies one condition, that no two adjacent houses are painted of the same color. But how will you satisfy the condition that this specific, obviously, if let's say this is the index 2, what is his mirror? Obviously, this is index n minus I plus 1. N is 8, I plus 1 is 3, so it will be index 5. So index 5 is his mirror, or I should say equidistant house. So you will say, okay, at this specific location, when you are at this location, you will have to say, what color did I actually put up at the parallel or at this specific index? Which means that you at a current index have to maintain the previous, that is obviously for sure, but then you, if again, if let's say you are at this specific j, you will have to maintain the prev, that is one thing. But if you're also going and saying that I will also maintain the opposite, or equidistant index, then it will give you complexity of I into j into prev. That's an issue, because if I go I is 1e5, j will also be 1e5, prev is nothing but three colors, which is 1, 2, and 3. So this will give me TLE. Now what to do? No worries. I just know one very basic stuff, that if I'm about to color this, right, I can also directly at the same point color this also, color this location also. But Aryan, if let's say you are about to color this location, then how will you color this location? Easy. If let's say if I place a blue here, then I can place either a green or a pink here. So what it means is, if let's say you have only two locations, you can place three possible colors here. Either you can place a blue or a green or a pink. If you place any one of the colors, then for this location, which is equidistant location, make sure it is equidistant location. For this equidistant location, you have only two possibilities. Anything other than what you have placed here, right? So if you place a pink here, then I can place only a blue or a green here, which means this will have two possibilities. So in total, for any specific index I, rather than trying for three possible options, now I will have six possible options. What these options really mean? These options means blue, green, blue, pink, green, blue, green, pink, pink, blue, pink, green. So rather than trying for just three possible options at this index, now I will try six possible options at the pair of these two equidistant indexes. Now, as you are trying for the pair already, which ultimately also means that you should only go up till the half of the array. Don't go after this half of the array, because if you start going half after this half, then you might start counting things again, which is overcounting, which you don't want. That is the reason you will only go up till the half of this array, and half of this array is nothing but n by 2 minus 1. Considering n is even, make sure n is even, thus half of this array is n by 2 minus 1. So anything more than n by 2, or I should say more than equal to n by 2, is, you should start returning a value that, okay, return, let's say 0. Why 0? Because if I just, okay, scroll up, I want minimum cost. So 0 will not add any cost, right? That is the reason I can start returning a 0 as soon as my index start exceeding my n by 2. Now, considering you got the idea, let's see how actually we can write it. We know that we will simply write a recursive function solve. It will have the index, it will have the previous color, which is this specific color. But is it sufficient? I will say previous color will help me to choose that, okay, if the previous color is green, obviously I can choose only these two. But do I only need only the previous color? No, not really. I also need this specific previous color, which means in the equidistant location, what was the previous color before it? Let's say prev2. This will say if this specific previous color would have been, let's say, blue, which means that this is gone, which means that, yeah, this is gone. I cannot now place a blue at this location, which is index n minus I plus 1. I cannot place a blue here. So now I have three options left. That is the reason for a specific index, which will give me 6 pairs, which I will try. Again, at max 6 pairs, obviously I will have to prune some pairs out, but I'll have to maintain the prev1. Prev1 will say what was the previous color just before the index I, and another is prev2, which will say what is the previous color before the index. What is the index? It is n minus I plus 1. Before this index, which is at the location n minus I, what is the color? So prev2 will say what is the color at n minus I location. Prev1 will say, again, this will say n minus I location, what is the color. This will say what is the color at I minus 1 location. This is what I will try for all the possibilities of pair of colors at the ith location, and also parallelly at I location, and also parallelly at n minus I plus 1 location. And ultimately that's the crux, which means, okay, as we saw just now, that the base case is that if my I becomes more than equal to n by 2, then simply return a 0. And the next thing will be, okay, simply if the dp of I prev1 prev2, if it is not equals to -1, prev2 it is not equal to -1, then you already have visited the same state, simply return that specific dp value, same value. Now comes the fun part, which is, result, which is my answer also. So by default I should initialize that by int max, because I want the minimum cost. So I will initialize that by int max, which is infinity. Then I will try for all possible pairs. As I showed you, I need to have all possible 6 pairs, right? All possible these pairs. So what I will do, I will simply have a for loop in which I will try for all possible colors from 0 to colors less than 3, and then colors plus plus. And then another is, again, just have another variable. You will say I will take, let's say, j variable for the first, and another, let's say, k. Let's say k is less than 3, and then k plus plus. So this will give me all possible pairs, but again, make sure that I will have to prune out. What is a prune out? Prune out simply means that this is the index, right? This is the corresponding index. But if you know that I am placing up the values, although I would have simplified it by choosing only the index also, because that would have also worked. But let's say I have another color mapping, which will say that at index 0, the color is 1, at index 1, the color is 2, at index 3, the color is, sorry, at index 2, the color is 3. So let's say you have the corresponding color mapping. Now again, why I'm showing this is because in the code you will see a color mapping which I have made as an array, and the indexes will say, okay, go on to that index to get a corresponding color. That's how I'm using it. Now coming on back, we simply realized one very basic stuff, that I will check that, okay, is it same? Firstly, I can simply ignore also. If j is equals to k, simply ignore, which means that I will have a if condition, that if, again, although you can write color mapping of j is not equal to color mapping of k, but again, it is more or less same, that j is not equals to k. And also I will just make sure that my j is not equals to prev1, but again, make sure prev1 is the color itself, so this is the index. So rather, let's write color mapping of j is not equals to prev1. And also the same point, I maintain the prev2 also, so mention color mapping of k is not equals to prev2, which means now this color mapping of j and color mapping of k is a good color pair, which I can place at the index I, which means that I know I have to minimize my result cost. So minimum of the result itself. And what I will do now, I should firstly assign the corresponding cost of the current color. So I'll say that cost at this current index. Again, cost is the input array. If you don't know, cost is the input array. If I just show you cost, this is the input array which is given to you. So I will say, okay, for the current index, which is the ith index, with this current color, which is color of j, I should say j, this specific j, right? This specific j, I will say this specific j. Give me that specific cost. And this is only for the current, but also for the equidistant one, which means for cost of n minus I plus 1. And the index will be k, right? The index will be k. And then just go and solve for the better index, which is I plus 1 with the current color, which I can simply pass by saying color mapping of j, and also the color mapping of k. This I can pass as the current colors for the next thing, right? Color mapping. This is also color mapping. Now again, just for your simplicity, I showed the indexes also. Although in the code also, because this is directly mapped, as you can see, this is directly mapped. Don't be confused when I show you the code, because in the code I will actually, instead of this j, I would have written color mapping of j minus 1, which ultimately directly mean the j itself. Thus you can replace by j also. But this is more simplistic in terms of reading the code, but logically if you simplify it, you can bring it down to this condition also. And rather than having a prev1 and prev2 as the, prev1 and prev2 as the color values, which is from 1, 2 and 3, you can also put up as 0, 1 and 2, because ultimately you're only concerned about the colors, so you can also forget about this color mapping altogether to simplify this, right? Again, it's totally up to your choice, whatever you want to do. Let's see the code, right? Now the code simply says that firstly, I initialize some global variables. I use ll for long, and I initialize the dp for I for prev1, and this is for prev2. Then I have the corresponding color mapping, although again it's totally up to your choice. If you want to use 0, 1, 2 also, then you can more simplify this specific thing. Okay, coming on back, you'll simply see that this is the corresponding base case, then my condition check, then going on to all the pairs, checking if, again, as I mentioned, you can replace this with j, you can replace this with k. Here if you put prev1 from 0, 1, 2, then you can replace this also with j, this also with k, because then color mapping of j will directly map to j, right? And but again, it's again for your simplicity, I will paste the code, although you will see that right now also I have pasted the corresponding code, right? But for your simplicity, I will also paste the code which is more simplified in the description below for you to check, which will be simply removing this line altogether and will directly be mapping the indexes with the colors itself. But right now, let's see this. Right, so I will get the current cost for the ith index and also the cost for n minus I plus 1 index, and then going and calling for solve for I plus 1, getting the answer, simply returning the corresponding solve. The time here, as you know, will be O of n into 3 into 3, and space also will be O of n into 3 into 3. Cool. I hope you guys got it. Again, it's a bit tricky, but it is more of in line with the other paint house problems which we have seen before. Bye bye. Take